so this video is going to focus on simplifying radicals. So simplifying radicals is not as difficult as you think. In previous courses, you've learned to simplify square roots, but this time we're going to learn to simplify higher roots, such as third roots, fourth roots, etc. Okay, so this little small number, that's called the index. It's important we all use the correct vocabulary so we know that we're talking about the same thing. The number under the radical is called the radicand. Okay, so what we're asking ourselves here is what is the third root of 125? So in other words, we want to know what can be multiplied 3 times to get 125? Okay, so you might be thinking, what is the answer to that? So it's actually 5, because 5 times 5 times 5 is 125. So when we're coming up with a cubic root, we're finding something that multiplied 3 times that equals that number. So let's go through some examples. Okay, I have 2 examples here. So let's first focus on example A. Alright, so on example A, we have the cubed root of 250. So we're first asking ourselves, what times itself 3 times equals 250? Well, the answer is nothing. Okay, so that's not a perfect cube root. So what I do is I'm going to first make a factor tree that you made back probably in elementary school. So I find the factors of it, 25 times 10, then I continue breaking them down until I have the prime factors, which are right here. I can rewrite those prime factors under the cubic root. So I have the cubic root of 2 times 5 times 5 times 5. Be sure to put them in numerical order because it just makes it easier when you're simplifying. So I rewrote them under here. Now, since I have the third root, I'm going to take out groups of 3. So I see that I have 3 5s repeated here. So every time I have a number repeated 3 times, I can take it out because it's a third root. So therefore, I take that out and I put that out here because it's no longer under the radical. And what's left under that is the cubed root of 2. Okay, so my final answer is 5 cubic root of 2. So let's look at this one. Now we're adding in another layer, so we're adding in a variable. So this time we have an index of 4. We have the fourth root of 48z to the 4th. So like I said, the first thing you want to do is you want to break down the 48. So I made a factor tree and I came up with the prime factors. So my prime factors were 2, 3, 2, 2, and 2. So again, I rewrite them under the root. So I have the fourth root. I write them in numerical order. And then I'm also going to expand my z to the 4th. So I write my 4 z's. So this time, since it's a fourth root, I want to take out groups of 4 because it's a fourth root. So I have 2 times 2 times 2 times 2, so I can take out 1, 2. I also can take out a z because there's 4 z's. So I take out a z. So I have 2z, but sadly the 3 is left alone in there because I only have 1 3, so the 3 has to stay in there. Okay, let's move on to the next 2 examples. Alright, so now we're going to talk about quotients, so simplifying when I have a quotient. So I have x to the 6th over 3 in example C. So in example C, I'm going to split it up. So I'm going to split it up into 2 different square roots. And these one are a square root. If I don't see an index, that indicates that it's an index of 2 or a square root. So first I can simplify the x to the 6th. So I wrote out my 6 x's and I took them out in groups of 2. And since I took out 3 groups, I have x to the 3rd. However, I still have the square root of 3 on the bottom. I have not gotten rid of that. So I have x to the 3rd over the root of 3. So hopefully you remember from previous courses, you cannot leave a square root in the denominator, so I have to do what's called rationalizing the denominator, which means I have to get an irrational number out of the denominator. So what I'm going to do, I'm going to multiply it by the square root of 3, and what I do to the bottom, I must do to the top, so that it's as if I'm just multiplying by 1, because multiplying by 1 doesn't change the problem. So I multiply the denominator and the numerator by root 3, so that then rationalizes my denominator, and I'm left with just 3, because root 3 times root 3 is root 9, which then simplifies to 3. At the top, I had x to the 3rd when I simplified up here, And now I had to multiply by root 3, so I have x to the third root 3 over 3. Okay, moving on to example D, I now have an index of 3 and I'm taking a third root. So I have the third root of x to the fourth over 2. As stated in the previous example, I split it into 2 parts. I then spread out my x's and I can see I have 4 of them. So that means 3 of them can come out. So you can see 3 of them come out, and that's one group of 3. So the cubic root of x to the third is just x. So I took one x out, and this one extra little x, he had to stay inside. So I still have the cubic root of x squared. Now at the bottom, I still have the cubic root of 2. So I still have that down there. I cannot leave that down there because I cannot leave irrational numbers in the denominator. So how am I going to get rid of that? Over here, I multiplied by the square root of 3, because 3 times 3 is 9, and the square root of 9 is 3. However, on here, because I have a cubic root, I need to multiply it by itself 3 times. So that means I multiply it by 3 times, so I have the cubic root of 2 times 2 times 2. And anytime I have 3 of something, I can take it out. So now my denominator is just 2 by itself. However, what I do to the denominator, I must do to the numerator. So up here, you can see, there's what I started with. Then I multiplied by the cubic root of 2, 2 times. So when I put it back together, I have x to the third. And then when I multiplied x times 2 times 2, I got 4x. And then I had 2 as my denominator. Okay, so if you just go right step by step, one step at a time, simplify it, you'll get the right answer. So, finally, to recap, when I solve these problems, for example, if I'm solving the cubic root of 40x to the fourth, when I solve them, I need to break down the number under the root using a factor tree. So step 1, use a factor tree. Okay, the second thing, write out all the prime factors under the radical. So I write out the prime factors in numerical order, and then if I have any variables, I can spread them out. Take out groups based on the index. This is an index of 3. I take out groups of 3. So I took out a 2x. Rewrite the problem. So the 2x came out, and the cubic root of 5x is still under there.